Good day, engineers. Para sa video natin is itutuloy natin yung sample problem for the design of double reinforced. So, natapos na natin yung design process and nakapagpalabas tayo ng design ng reinforcement ng beam natin, which is ito. And now we have to confirm if this design of the beam is safe for the actual ultimate moment of 320 kN. So, isasubject natin siya on the analysis process. So, for the analysis, ang una natin gagawin is to get the steel areas. So, punta muna tayo on the part of the tension steel. So, that will be AS is equal to, so we have 5. So that is 5 times pi over 4 times 25 squared. So that will correspond to 3125 over 4 pi. So that will be our AS. Then, yung A prime S natin, so we have A prime S. Dalawa lang naman yan. So, that is 2 times pi over 4 times 25 squared is equal to a value 625 over 25. So, yan na ngayon yung ating steel areas for compression and for tension. By the way, since hindi stated sa problem kung nasa ng compression, nasa ng tension side, we just assume that compression is at the top and tension is at the bottom. Pero kung merong sign or direction, yung ating actual ultimate moment, kailangan nating sundin yung proper arrangement of the bars for compression and for tension. So, after getting our steel areas, syempre, kailangan na natin i-determine yung effective depth and yung distance from the extreme compression fiber to the centroid of the farthest reinforcement. So, bago natin i-determine yun, alam natin na kailangan natin ng value y bar. Kasi nga, yung reinforcement natin is in 2 layers and unequal yung number of bars for the first layer and the second layer. So, we need a centroid of the reinforcement coming from its bottom or extreme bottom reinforcement or pinakababa nung first layer reinforcement. So, that will be y bar is equal to, so from Varignon's theorem, so sa first layer meron tayong tatlo, 3 times pi over 4 times 25 squared. Then we will be needing yung centroid niya which is just 25 over 2. After taking that one, we have to add yung dalawa sa second layer times pi over 4 times 25 squared. So, yun yung area ng second layer. Ngayon, kailangan natin yung centroid niya. And alam natin na this is 25, this is 25, at yung spacer na gagamitin natin for this two-layer reinforcement is 25 din since diameter 25 mm yung diameter ng bars. So, that will be 25 over 2 plus 25 plus 25. So, that is divided by yung total area ng steel natin, which is 3125 over 4 pi. So, getting the value or calculating, we will have a value of y bar which is 65 over 2 mm. So now we can proceed in getting its effective depth. So for our effective depth, syempre, so that will be equivalent to, so ito naman yung effective depth natin hanggang dun sa centroid. So kailangan lang natin ibawas dyan yung clear cover na to, yung stirrups, ito, at yung Y-bar itself. So, that will be 550 minus 50, yung clear cover natin, minus yung diameter ng stirrups na 10, and minus yung Y-bar, which is 65 over 2 mm. So, we can have a value of an effective depth, which is 915 over 2 mm. Since this is a double layer reinforcement, we will be getting the distance of the extreme compression fiber to the centroid of the farthest reinforcement. So, medyo may error lang dun sa diagram natin. So, hanggang dito lang yung DT na yan. So, hanggang dito. So, this one is erroneous. So, this one. Hanggang dito lang siya. Sa gitna ng farthest reinforcement. And that is DT. So, to get DT, we just have, that is 550 lang, minus 50, minus 10, minus 25 over 2, which is yung kanina nating value na 955 over 2 mm. So, this is coming from our previous video on the design process. Then, kunin na din natin yung D' natin, which is the same dun sa design process natin. So, that is 50 plus 10 plus 25 over 2. So, that is a value 145 over 2 mm. So, ngayon meron na tayong values ng effective depth, the distance from the extreme compression fiber to the centroid of the farthest reinforcement, and yung value ng concrete cover ng compression reinforcement, which is D'. Now, alam naman natin na doubly to. Pero, for the purpose of checking, dun tayo sa design process, tingnan natin yung balance condition or yung balance still ratio, yung maximum still ratio, and minimum still ratio for this one. I-check natin sa actual still ratio. So, check natin yung actual. So, our actual still ratio natin is just AS over the BD. So, AS natin dito. So, ito na yung actual AS natin, which is 3125 over 4 pi. Divided by B, that is 300 times yung D is 915 over 2. So, we could get a raw actual approximately 0.017882. Check natin yung maximum still ratio to verify yung ating assumption that this is a doubly reinforced or to be analyzed as a doubly reinforced. So, that will be 3/8 of 0.85 F prime C beta 1 over Fy times dt over d. So, that will be 3/8 times 0.85 times 21 times beta 1 is 0.85 divided by Fy, which is 415. Then, times dt, which is 955 over 2 divided by 915 over 2, which is our d. So, we can have a value of raw max equivalent to, that is 0.0143. So, as you can see, our raw required is greater than our raw max. Or raw actual that is raw actual is greater than our raw max. So, therefore, it is true that we can assume that this is a doubly reinforced beam. Then, check natin yung raw balance kasi pwede natin malaman kung over-reinforced to or under-reinforced. So, for our raw balance, that is equivalent to 0.85 F prime C beta 1 over Fy times 600 over 600 plus Fy. So, that will be equivalent to 0.85 times 21 times beta 1 is 0.85 divided by 415 times 600 over 600 plus 415. So, our raw balance coming from this equation will be 0.021612. And as you can see, this is far greater than our raw actual. So, that means safe pa yung steel ratio natin. Nandun pa siya sa part ng under-reinforced. The difference is such that nasa doubly reinforced beam siya. Then, check natin yung raw minimum kung pumapasok yung steel natin or yung steel ratio natin na actual. So, since ang F'C natin is lesser than 31.36 approximately megapascal. So, pwede nating gawin na our raw mean is equal to 1.4 over the Fy. So, that will be 1.4 over 415. So, that is approximately 0.003373. So, that is lesser than our raw actual. So, therefore, nasunod niya yung code and we have to use the raw actual. So, wala tayong problema on the part of our designed beam dun sa mga steel ratios. So, for this one, we could now proceed in analyzing our designed beam. So, we have to go through an assumption na, so let's assume yung compression steel does not yield, and we have to go through tension steel yields. Kasi may idea na tayo on our previous video na yung compression doon hindi nag-yield pero yung tension is yielding. So, we have to go through this assumption and we have to use these diagrams for our assumption. So, getting those diagrams and using the static equation from these diagrams, so we have C1 plus C2 is equal to the T. So, T is T1 plus T2. So, from this one, we could say that is 0.85 F prime C AB plus A prime S. So, since assumption natin is still does not yield, so, pasok na agad natin yung equation na 600 times C minus D prime over the C minus 0.85 F prime C. That is equal to AS Fy. So, let A is equal to beta 1C. So, substitute natin. That is 0.85. F prime C, beta 1 CB plus, so that is A prime S times 600 times C minus D prime over the C minus 0.85 F prime C is equal to AS Fy. From this equation, we could multiply both sides by C. So, multiplying both sides by C, we could have an equation 0.85 F prime C beta 1B C squared plus yung C magka-cancel out dito sa equation na to. So, AS magiging 600 A prime S. That is C. So, yung sunod is minus 600 A prime S D prime. And yung sunod is minus 0.85 F prime C A prime S. Syempre may C na siya. Then is equal to AS. So that is multiplied by C. So that is C. Then arranging the term and adding similar terms. So ito, transpose natin dito. At isama natin dun sa mga values na may variable C. So that will be 0.85 F prime C beta 1B C squared plus that is 600 A prime S minus 0.85 F prime C A prime S C, or wala mo na si C, then ito magiging minus kasi tinranspose natin, so that is minus AS FY, then that is C minus 600 A prime S D prime is equal to 0. Now, syempre, pwede natin gawin that this part is A. Then, this will be B. Itong buo. Then, this will be A value C. So, kunin natin yung A value. So, our A value will just be 0.85 times 21 times 0.85 times the value V is 300. So, that will be a value 18,207 divided by 4. Yan ngayon si A. Si B naman, that is equal to, so 600 times A prime S, that is 625 over 2 pi minus 0.85 times 21 times A prime S natin is 625 over 2 pi minus 3125 over 4 pi times 415. So, calculating this value, we could get negative 1138,375 over 8 pi. Then, proceed tayo dun sa C, which is a value negative 600. So, may negative sign kasi dun. Times A prime S, that is 625 over 2 pi times D prime is 145 over 2. So, that will be a value negative 42,706,025.13. So, yan na ngayon yung tatlo, and pwede natin siyang kunin using the function of our calculator for quadratic equations, or we can use the quadratic formula. So, by using the quadratic equation function ng ating calculator, kukunin natin yung pinaka appropriate value of C, which is equivalent now to a value of 157.7053. So, this is in mm. Ito ngayon yung C natin. Then, proceeding in getting the value of the depth of compression block, we have A is equal to beta 1C. So, that is 0.85 times 157.7053. So, our A now will just be equivalent to 134.0495. So, this is in mm. So, ngayon, we have to verify the values or yung assumption natin if the compression steel are not yielding and yung tension steel natin is yielding. So, we have to use yung equation natin for F prime S and Fs. Start tayo for the compression side. So, termin natin si F prime S. So, that will be 600 times C minus D prime over the C. So, that is 600 times C is 157.7053 minus D prime will be 145 over 2 divided by 157.7053. And this F prime S has a value of 324.1691. And as you can see, this is in megapascal and this is lesser than our yield strength. Therefore, compression steel does not yield. Tama yung assumption natin on decompression. Hindi pa natin pwedeng i-conclude kung tama yung assumption natin on tension or yung lahat ng assumption natin. So, verify din natin yung tension. So, Fs is equal to 600 times D minus C over the C. So, that is equivalent to, so, dito tayo sa side. So, that is 600 times D. So, that is 915 over 2 minus yung C natin na 157.7053 divided by 157.7053. So, that will be a value of Fs which is equivalent to 1,140.5883 megapascal. And this is greater than our Fy or our yield strength. Therefore, the tension still yields. So, since tama yung assumption natin, we can say na this value of C is a true value or a correct value and this value of A is a correct value. Now, after proving our assumption, so we have now to determine the net tensile strain. For our net tensile strain, syempre kakailanganin natin yung strain diagram. So, strain diagram, ito. So, lakayan lang natin. So, syempre, from this strain diagram, kukunin lang natin yung farthest or yung strain for the farthest reinforcement. So, this is just coming from similar triangles ulit, yung upper triangle and yung lower triangle natin. So, that will be 0.003 divided by the value C is equal to epsilon T, that is dt minus C. So, that will be epsilon sub T is equal to 0.003 dt minus C over C. So, pinunta lang natin doon yung dt minus C. So, that will be equivalent to, so, isin natin to. That will just be equivalent to 0.003 times the dt which is 955 over 2 minus yung C natin is 157.7053 divided by 157.7053. So, our epsilon sub T now will just be equal to a value 0.006083. So, this is greater than 0.005. So, our beam is ductile and still, our reduction factor will be 0.9. So, hindi natin kailangan yung equation for the reduction factor. So, pwede tayong rumekta na that is 0.9. After getting the reduction factor, pwede na natin kunin yung nominal moment by using the stresses or the stress diagrams. So, ito siya. So, since analysis part na to, so we have to analyze this beam by getting all the values or all the values of our moments from decompressions or from decompression side. So, ibig sabihin, punta muna tayo ng MN1. Sa MN1 kasi, kunin natin siya on the compression side using C1. So, that will be C1 times D minus A over 2, or that is 0.85 F prime C AB times D minus A over 2. So, substituting the values, we could have 0.85 times 21 times yung A na nakuha natin, yung true value, which is 134.0495 times 300. Then, multiplied by 915 over 2 minus 134.0495 over 2. Siyempre, multiply natin to by 1 over 1,000 squared para maging kilonewton meter. So, our first nominal moment coming from our first diagram will be 280.2968. So, this is in kilonewton meters. For our second nominal moment, manggagaling lang siya on the second diagram and galing sa compression side, which is for the compression reinforcement. So, that is our MN2. MN2 is just equal to A prime S times. And na-prove natin kanina na compression steel does not yield. So, that is F prime S na na-compute natin kanina minus 0.85 of our F prime C times D minus D prime, which is the moment arm shown in this figure. So, that will be a value. A prime S natin is 625 over 2 pi times F prime S na nakuha natin kanina is 324.1691 minus natin yung 0.85 times 21, then multiply natin yung 915 over 2 minus yung D prime natin na 145 over 2, at i-multiply natin siya sa 1 over 1,000 squared. So, our second nominal moment will just be equivalent to a value 115.7803 kilonewton meter. And adding those two nominal moments, we could get the nominal or the total nominal moment. So that is MN1 plus MN2. We could have a total nominal moment equivalent to 396.0771 kilonewton meter. So, hindi pa natin to pwedeng i-compare dun sa 320 kilonewton meter na actual ultimate moment kasi nominal pa lang siya. So, to make this one ultimate, we have to multiply this by our reduction factor, which is 0.9. So, 0.9 times our nominal moment, 396.0771. So, that will be a value 356.4694. So, this is in kilonewton per meter. And as you can see, yung ultimate moment capacity ng ating beam is much greater than our actual ultimate moment, which is 320 kilonewton meter. Therefore, yung design beam natin is safe. And we take yung design natin na beam from the design process as the final design. So, this will be our final design. So, that will be all for our sample problem on the analysis part regarding the design of doubly reinforced beam. Again, this is Engineer Rodolfo. Thank you for watching and don't forget to subscribe to Butch TV.